So the OpenCAE case study for the Europa lander concept. So before I tell the story about how we worked on the Europa lander flight systems engineering team, I'm going to introduce some of the characters and settings that are important for a story. So I'm going to talk about what OpenMBE is and what OpenCAE is and how they relate. I'm going to talk about what Europa lander did at the beginning before we started this effort to adapt those concepts to our very specific engineering needs. And then I'm going to talk about some of the things that they need to produce for JPL, the system engineering products. And then I'm going to talk about how we did all that. So here we go. Open model-based engineering environment is a community out there. So there's a URL at the top, so you can all go, download on your phones and check out the OpenMBE community. A lot of people talk about it as kind of the open source sharing of these models and policies and lessons learned, as well as the software tools and stuff that enable these efforts. JPL is a participant in this community, and along with a lot of other organizations from varying sizes and involvement. We have also the vendor participants as well, which is great. And as of the time that I made this slide, there are approximately 200 members, but I'm sure the membership is just skyrocketing right now, right? And everybody's downloading. You may have heard of us from this core integration of the model management system, the model development kit, and view editor. So these are software downloadables, and the grouping of which people also call it OpenMBE. So because system engineers like to reuse words. So these things here are a core integration of open source software that's available for people to install and to run with. And so the MDK is a plugin for Magic Draw, and this iteration of the MDK, and then it publishes all the data back into the MMS, and then documents are served up on View Editor or Views, and then you can edit back into the database. So some people might be more familiar with that than the rest of the other OpenMBE stuff. Okay, now total aside, we're going to talk about CAE. That's the group that I work in at JPL, a computer-aided engineering group. CAE provides the engineering tooling and support for all the engineers at JPL, because there's a lot of projects at JPL, but a lot of them have the same needs and concerns, so we group it all together in CAE, and then we try to answer their questions and support them all as a lab entirely. Big happy family. CAE is divided into 4 engineering disciplines, as you can see up there. I work in the systems engineering discipline, so we support these 4 different environments in what we call OpenCAE. So with OpenMBE has this community and philosophy of openness and articulating these environments. OpenCAE is kind of exactly the same thing, just only at JPL, where we have these communities and environments where we can talk about engineering problems and talk about things that we need from either vendors or maybe the CAE team itself. So here's what one of these environments looks like. This is what we call the seat at the table diagram. So this is just for the systems environment in which I work. So what you see on this diagram here is in the middle, you see a bunch of databases and kind of web services or service tools in the middle that store your data and version control things and also can run huge heavy analyses. And then surrounding them is a border that we've labeled web services. And then on the outside, all the seats at the table are these engineering tools, which can connect into this heterogeneous model storage environment right here. And then if you recall the 3 things for which OpenMBE is known, this is how they integrate into our environment. So we see Magic Draw and MDK, and then that connects through web services to the MMS, and then we can pull out the documents and views on View Editor. So they're highlighted in red there. So that's how JPL has adopted the OpenMBE framework into our very specific engineering environment that we do at CAE. So this is kind of the setting for the Europa lander study. The Europa lander study is one of the many, not quite customers, but members of the CAE community, OpenCAE. And basically, this is a study that is proposed by NASA JPL. Europa is a very interesting place in our solar system. We believe that there is a salty ocean of more liquid water there than even on Earth, and the reason for that is because of the crushing gravitational effects of Jupiter are thermally affecting Europa itself just by crushing it as it orbits around for eternity. So we are very interested in this, and we'd like to go over there and send a little lander to drop down and scoop up some ice and give it a taste and tell us what it sees. So it's really cool. And this is all sourced from the Europa Lander report, not the movie, the actual report on NASA JPL. So you should check it out. It's quite interesting. So the table that we saw earlier, the Europa Lander study, the flight system engineering team, we only needed a handful of the tools that were at the table. So with help from CAE and then also the flight system engineering team telling us what they needed, we selected these tools to kind of handle our engineering day-to-day. And of course, there were other ones that were involved, of course, but it's only a 20-minute presentation. Oh, and there's a cool artist concept of the lander, and you see its little fishing pole sticking out. It's going to drill in the ice and pick some fish up, I guess. So, very exciting. Okay, one last thing to introduce are the JPL Systems engineering products. These are the official gate products that we have internally at NASA JPL. These are the things that go to our big reviews. These are the things that the management wants to see. All the not only just the studies, but all the missions have to conform to these kind of engineering products for systems engineering. In this talk, we're going to talk about these in basically a random order, so because they build the story along. So now we're ready to talk about what we actually did. All right. So for the first product that we're talking about is the master equipment list, or just the MEL. This is something that the systems engineering teams keep track of the attributes of each of the components that they want to use on their spacecraft. Mass is very important, so some people refer to this as a mass equipment list, but there's other things on there they have to account for as well. So we track all those things in order for the engineers to know exactly how much everything weighs, because it's important for the rocket equation. So it's just a table in Excel. Is when I showed up to the team, that's what it was, table in Excel, email back and forth. And they wanted it to be more model-based because, as you probably can expect, even a slight difference in mass matters a lot, and this continuity and precision of data is hugely important for rocket science. So what we did instead was we used some of the tooling that was in the systems environment. So we took, so their Excel sheet we could take and pretty much bring it into a tool called Maple MBSE. We encoded, that encoded all of these components and attributes into SysML blocks, which were stored into our web services there. Don't need to worry about the databases, they're there. And then additionally, we could edit the components as they're going on, so this is the kind of continuity piece. And then additionally, we could use a tool called Zendaya to connect to their mechanical system engineering CAD model and pull that stuff over and make sure that, hey, if we're talking about this motor controller, it weighs the same thing in the CAD or the system engineering MEL, which was done by hand forever. So that was a big deal as well. And then all of this stuff, we would represent the MEL into views on ViewEditor, because since ViewEditor can connect in through those web services to all these databases, it can pull out the MEL into a web page that people can look at and also edit and send it all back and reflect it throughout the whole model. So that's what we did for this very strict accounting component attribute list. So another product that we had to produce is the compositional system design. To borrow the metaphor that one of my colleagues used on Lander, if the MEL is the box of Legos that you have with all the specifications of each Lego, the compositional system design is how you assemble those Legos together in assembly structures and mechanical structures, just what contains what. So very similar, but a slightly different product. And you can see a piece right there. So, and it's just a standard system composition structure. So what we did, similar tools. So we, pulling over from the CAD model, we got a lot of the mechanical structure over there, but just right into the databases. But there's also a bunch of kind of system assembly structures that aren't real. They're not actual hardware, but they're groupings of things that people would like deliver or talk about in terms of what system engineering team is responsible for them. So we could also use MBSE again, so for the system engineers to work in their natural habitat, which is Microsoft Excel, you know, like it or not, they were able to enter in these system assembly views into the database. And then we also used Magic Draw with the MDK because it's also pretty good at building out these graphical representations of compositional hierarchy. So, and then naturally, of course, we exposed a very specific view on View Editor that describes the entire compositional system design, so managers can log into a web page and they can see graphs and they can see like the roll-up of specific subassembly and see, you know, they know who to email. It's like, why did your mass grow so much? And they say, well, you know, X reason or whatever. So that's how we kind of informed everybody within the database, or from all the system specification in the databases. All right, so the system block diagram is similar to both, and but it's a different kind of product that people need to provide at the reviews. So once you have all of your Lego pieces and Legos assembled into a structure, you also need to connect them, especially if they're powered or they share data or something. So this is what the engineers would typically do in just some graphical design tool, but since we're using system or model-based system engineering, we had a better solution for that. So we already had the compositional system, you know, system hierarchy all in there, and then it was only a matter of going into Magic Draw and taking the actual usages of all the components and drawing a line across and saying, hey, these things are connected by this kind of power wire, like space wire is one of them, which is cool. I think it's cool that we call something space wire. And then we were also able to audit all those connections in MBSE as well, just to check, you know, how many, like numerically, how many things are connected to this thing. We could query that out. And then using Tom Sawyer, we could pull out that SysML data, because it's all the same language, and then represent these, and I'll go back actually, these beautiful and interactive diagrams where people can close and expand different system subassemblies, which are all the same exact language that they use to talk about these things when they talk in Excel, because it can't not be the same thing, because we're using the same web services. And so we were able to use Tom Sawyer to visualize and lay these things out. And also in View Editor, there's a plugin for Tom Sawyer, so we could do it right in line with their documents that they were already writing. So they were pretty happy about that. And the final one I want to talk about is this kind of behavioral stuff that we needed to provide. So they're in the list, there are two different things, but on Lander we kind of dealt with them the same way. This definition of scenarios, and then the power equipment list, or the PEL. So basically there's a subset on every spacecraft of the master equipment list that are powered items. They're things that not only are just on and off, but some of them have different modes, like they're on wait, sleep, or hold, or they, you know, all engineering defined modes of the components. And then, so the way that the engineers like to do it, at least in this team, was they like to prescribe the behavior of all these subcomponents based on the full scenario that the system went under. So when your spacecraft is here it says, when your spacecraft's in cruise mode, or in the cruise scenario, then that list of subcomponents from the PEL need to be in these different states. So it's kind of a prescriptive model of behavior. So, and naturally all done in Excel. And then, of course, the specific components themselves had, for each of their power modes, they had power usages. So the interest was to see the roll-up of power as the system moves through time, which is just behavior. So in order to do this, we once again leaned on MBSE to kind of import the Excel that they already had, and then so that worked out. And then what was also kind of nice about that is when I arrived there, they were already using Phoenix Model Center to do analysis on the full scenario runs, right? So they would do it to like alter little things here and there, and they would use the Excel as the input because that's all they had before. And since we were using MBSE, they didn't have to really retool it that much because you can export it to Excel and then you can still use it in this kind of heterogeneous tooling environment. And then naturally we would expose back out into View Editor with all the documents for, you know, the upper level managers, what the scenarios are, the roll up of the power in each scenario and things like that. All right, and I think that was the only 4 I was going to go through. So I got 2 minutes left. Basically, so we're supporting the engineering effort on Europa Lander to this day. I'm still working there. And so we took kind of this, this model-based engineering approach that we all talk about at these conferences, and we talk about in the OpenMBE group. And so, and we brought it down in through, kind of filtered it through to meet the JPL specific stuff with the OpenCAE stuff. And then since I was working like in the trenches with these engineers, I was able to take in their direct and sometimes aggressive input on what they needed to do in order to meet these gate products. And what was really good about that is since we learned so much from these, from the flight system engineers there, we're able to pull that back up into OpenCAE, fix our environment to better meet the needs of our engineers that we're supposed to serve, and then eventually it'll propagate back into OpenMBE. So here's my receipt, a bunch of Wikipedia links, and actually I'm running early. All right, thanks.